Hi children, welcome to today's online class. And before going to today's topic, I just want you to recall the previous actually concepts what you have learned. Okay, what in the previous class. Uh, Number one, what is that? The refraction. I think in the previous class we have learned something about refraction. So what is refraction? Refraction of light. See the change in the path of the light when the light travels from one medium to another medium. Therefore, why? What is the cause of refraction when the light goes from one medium to another medium? The speed of the light, that is the velocity of the light, it changes. Because of the change, what it does, it bends from its original path. Okay, how it bends, that is a question now. When the light goes from rarer to denser medium, it bends towards the normal, and when it goes from denser to rarer medium, it deviates away from the normal. Okay, and also we have learned something about what is that as law of refraction, that is Snell's law. In Snell's law, what is Snell's law? It is sin I by sin R. What is I? I is the angle of incidence. R is the angle of refraction. It is the angle between the incident light and the normal is I. Angle between the refracted ray and the normal is R. Therefore, it's sin I by sin R. That is nothing but, I think we have seen, that is n/1. That is refractive index of the second medium with respect to the first medium. And that is nothing but absolute refractive index of the second medium divided by absolute refractive index of the first medium. Everything I think we have seen, and that is nothing but the velocity. This is, I want to represent the same with respect to the velocity, that is the velocity of the light in the first medium divided by the velocity of light in the second medium. Therefore, this is named as Snell's law. Okay, that is the ratio between sine of the angle of incidence and sine of the angle of refraction is a constant. That is a condition, okay, for the given wavelength of the light and for the given pair of the medium, for a given pair of medium and for the given wavelength of the light used. Okay, and you know that rarer and denser medium, if that is the refractive index will be more if the medium is denser, and if it is a rarer medium, refractive index will be comparatively, it will be less. And for air, the refractive index is 1. These things you have already learnt. Okay, so now with this, numericals we will see afterwards. Okay, now with this, let me go to, now we are going to the next topic. What is that? It is a refraction of light by spherical lenses. Okay, so what is a lens here now? Before going to this, lens is nothing but, you can say, it is nothing but a transparent medium, which is bounded by two surfaces. A transparent medium which is bounded by two surfaces, and these two surfaces, what is the shape of the surface? Two surfaces. See, there should be one medium which is bounded by two surfaces. And what is the shape of the surface? Out of these two surfaces, one definitely it has to be a spherical surface. Out of the two surfaces, one has to be mandatory, one should be a spherical surface. Okay, other may or may not be a spherical surface. Okay, therefore, depending upon the shape of the surface, two surfaces, depending upon the shape of the two surfaces, we can classify the lenses, okay, into different types. Are you following? See, what is a lens? Lens is nothing but, it is a transparent medium which is bounded by two surfaces, of which mandatory one has to be a spherical surface. Other may or may not be. Okay, and depending upon the shape of the surface, you can classify the lens into different category. What are they? See, for example, number one, first one, let me have, okay, lens. For number one is you can say biconvex lens or double convex lens. Both are same. Double convex lens. What do you mean by that? See, biconvex or double convex lens. What is that? It is a transparent medium which is bounded by both the surfaces should be, what is it here? Convex. Biconvex. Both the surfaces are convex. Therefore, how to draw the biconvex lens? Like this. Are you following? This is one convex. This is the, what is a convex surface? And this is also the convex surface. And inside the medium, what is that? There will be a transparent medium. Okay, transparent medium of any color. Okay. This is the, here the inside, what is that? That is a transparent medium. Are you following? So, what is that? First one is, see, it is a biconvex lens or double convex lens. So, transparent medium is bounded by, what is that? Convex surfaces. Both inside, what is that? Here, this is nothing but, okay, this is the transparent medium. Are you following? This is the transparent medium and it is bounded by what? The convex. Both the surfaces. This is also convex and this is also convex. Therefore, this is what is called, what is that? Convex lens or biconvex. Both the surfaces are convex. That is why it is biconvex or it is what is called double convex lens. Okay, right. Next one. As I told you, depending upon the shape of the surface, you can name the lens. Next one is, what is that? Biconcave lens or double concave lens. Okay, both are, what do you mean by that? Both are concave. Both the surfaces are, what is it? Concave. Therefore, A concave, this side also concave. Okay, therefore, in between, what is that? A transparent medium. Therefore, this is the transparent medium. Are you following? So, a transparent medium is bounded by what is that? Two concave surfaces. Therefore, this is what is called, both the surfaces are concave in nature. So, it is what is called biconcave lens or double concave lens. Okay, right. Is there any, now in our this class, no, we are going to deal only with, what is that? Biconvex lens and biconcave lens. Okay. So, apart from that, but you should know the there are other interesting what is that? Lenses also. What are they? See, for example, you can say plano convex lens. What do you mean by plano convex? Plano convex, that itself it's very clear. One side is plane, plano, and other side is convex. Other side is convex. Therefore, it is what is called plano convex lens. Therefore, in between, what is that? The medium, the transparent medium is bounded by one plane surface and the other one is what is called the convex surface. Therefore, it is plano convex lens. Okay. Therefore, next one. Next one, definitely plano concave lens. Plano concave lens means what is that? One side is plane. Okay. The other side will be concave. One side is plane. The other side is concave. Are you following? Whether you are able to see, this is a concave surface. If I want If you want, I can even better curvature I'll give. See, this is, okay, one side is plane, the other side should be concave. Okay, therefore this is what is that? What type of lens is this? It is a plano concave lens. But this is the medium, transparent medium. This is bounded by one plane surface, the other one is concave surface. Are you following? So this is a concave surface now. See, it is a concave surface and another surface will be plane, like that. Are you following? Therefore this is a what is that? Plano concave lens. Okay, like that you can have so many convexo-concave, convex for one surfaces, convex, convexo-concave. One just I'll give you what is convexo-concave. Okay, how to convexo-concave? First side is convex. Okay, the other side will be concave. Correct? This side is concave and this side it is convex and this is concave. Here it is plane and here it is concave. Are you following? Like that. Therefore, here it is convexo-concave. Therefore, if you see inside, that is a transparent medium. Every time there is no need to show the transparent medium, it is understood, but now because to start with, just is it clear? Therefore this is a convexo-concave. It is a convexo-concave lens. This side is convex and the other side is concave. Are you following? So these are all the concave or convex, everything is there. Okay, therefore, but what we are going to deal with, okay, is only biconvex and biconcave lens. But there is no need for you to every time say biconvex. Just simply you can even say this one as convex lens. Convex lens means both the sides are convex. The transparent what is the medium is bounded by two convex surfaces. Here transparent medium is bounded by two concave surfaces. Therefore it is a concave lens. Are you following? Okay, so these are all, what is that, the different types of lenses. Okay, so now with this, okay, we will go to a very, see, now what are all the important terms in this. Okay, so important terms, for example, see, as we have seen in our mirror, no, like that. So let me have, see here, let me have first convex lens. Okay, with respect to convex lens, let me give you, see here, what is that? This is the lens, correct? But the here center, what is that? That is a transparent medium, right? And these this is a spherical surface. There are two spherical surfaces now. So this is a spherical surface. Say I'm drawing, see here, this is the spherical surface, and which means that it is nothing but a part of a sphere. The spherical surface should be a part of a sphere, for which there will be one center. Are you following? This center name I am giving C1. Like that, there is what the two spherical surface. This spherical surface is there, no? This is also the spherical. So let me thicken this. I am showing this. This is also the spherical surface. That is also a part of a sphere. The spherical surface is nothing but a part of a sphere. For that there will be one center, and that is C2. Are you following? Is it clear? Therefore, C1 and C2 are center of curvatures. Okay, this is C1 is the center of curvature, first center of curvature, and C2 is the second center of curvature. Are you following? Center of curvature means what is that? Because there are two spherical surfaces, okay, and each spherical surface is a part of a sphere. Center of that sphere is what is called, the center of curvature. Are you following? Therefore, the lens, it has now two center of curvatures. Now let me rub this one. There is no need to show this one every time. Okay. Okay. Now, because for your understanding, I have drawn. Now, see, here the center of curvature is there now. Right. Now, next one is, what is the center of the lens itself? Center of the lens is what is called optics. Oh, that is what is called optical center. Optical center. Okay, therefore the line joining both the center of curvatures and the optical center, everything. Okay, this one, this straight line joining this, and this is what is called the principal axis. This is what is called the principal axis. Are you following? Okay, therefore, now usually the center of curvature, see here, it will tight slightly. I'll draw properly here. See. Okay, so C1, C2 or center of curvature. O is the optical center of the lens. Like that, concave lens also the same thing. Concave lens, if you are doing, see, this is a concave lens, na? Okay. Okay. Now here, for this is nothing but a part of a sphere, this surface. Okay, it has some center. This is C1, and this is nothing but a part of a sphere. It has some center. That is what is called C2. Okay, and the center of the lens is what is called O. Line joining all the three is what is called the principal axis. Are you following? So now it is, we have seen mirror, the same thing here. Mirror is a reflecting surface and lens is a refracting surface. Are you following? It has refracting surface. That's it. Okay, is it clear? Mirror reflects, but lens refracts the light. That's all. Okay, right. Now with this, we will go to, so these are all, and this is, now you know what is the center of curvature and what is that optic center, everything, right? Now, usually see, now we are going to see a very important topic. What is that? Principal focus. Now we are going to see principal focus. Okay, let me have this one. Okay, what is principal focus? We are going to see. Okay, now principal focus of first, which lens? Convex lens we will see. Okay, so principal focus. Okay, first one, what is that? Convex lens. Convex lens. Okay, see, take a convex lens. Let me draw. Okay, so even the lens now, what we are dealing here with is a thin lens. What in thin lens? The radius, what is that? The diameter of the lens, the physical diameter of the lens, okay, is very small. That is what a diameter is small means. The diameter of lens is what is called aperture. That is what is called aperture. Okay, therefore aperture means diameter is very very small, means that lens is what is called aperture is very small, diameter of the lens is very small, and that is what is called thin lens. The lens is what is called thin lens. What we are going to deal here, okay, is only what is that thin lens. We are going to deal only with the thin lens. Okay, right. Now, okay, therefore now let me draw principal axis. Okay, now what is principal focus of convex lens? See the rays, see I have so many rays with what is that, rays parallel to the principal axis. I have so many rays which are parallel to the principal axis. Okay, right, which after refraction, it is after refraction only. Why? Because outside here it is air and here it is a transparent medium, usually it will be glass. So it is going from air to glass, correct? So once it passes through, when after refraction, by which lens? A convex lens, okay, will converge up to center, you bring, will converge at a point after refraction by a convex lens, will converge at a point lying on the principal axis, lying on the principal axis, and that point is what is called the principal focus, F. That point is what is called the principal focus of convex lens. F is what is called the principal focus of which lens? Convex lens. Are you following? Therefore, how to define the principal focus of a convex? See, the rays, light rays, which are parallel to the principal axis, after refraction by which lens? A convex lens, will after refraction, what is that? The rays are converged, okay, at a point which is lying on the principal axis. That point is what is called principal focus of a convex lens. Once again I repeat, okay, the rays, the light rays parallel to the principal axis. This is the principal axis, this is zona, okay, therefore it is optic center. Therefore the light rays parallel to the principal axis, which after refraction by a convex lens, okay, will converge at a point lying on the principal axis, and that point is called as the principal focus of the convex lens. Okay, therefore this principal, this is very very important, principal focus, it is a principal focus. Therefore I think from this itself, in the case of mirror, you recall the mirror, in the case of mirror, see what is the principal focus of a concave mirror? Concave mirror, the rays parallel to the principal axis, which after reflection by a concave mirror will converge at a point lying on the principal axis. Okay, therefore this is also convex lens also converging. After refraction it converges. Like that in the previous case, mirror, concave mirror also, what is that? It is after reflection by a concave mirror, the rays will converge. So concave mirror is called as a converging mirror now. Like that here, this is convex lens. Yes, okay. What is guys? Is a converging lens. Why? Because when the light passes through a convex lens after refraction, the light rays will converge. That is why it is what is called a converging lens. Hope you are following this. Is it clear? Therefore, what is principal focus? Principal focus of a convex lens. It is the rays parallel to the principal axis, which after refraction by a convex lens will converge at a point lying on the principal axis, and that point is what is called principal focus of a convex lens after passing convex lens. Therefore, convex lens is a converging lens. Okay, right. Now, next topic. Now we are going to the same thing for what? The concave lens. Principal focus of a concave lens. Anyhow, I'll try once again. Yeah. Because okay. So now we are going to what is that? Principal focus of concave lens. Okay. So how to first concave lens? You draw concave lens. Yeah. This is a concave lens. Okay, that is okay. Now what is that here? This is optic center. Okay, and this is okay. Let me draw in the other color, the same, because yeah, this is your optic principal axis. Okay, right. Now what is principal focus? Define principal focus of a concave lens. Okay, very simple. It is, what is that? In the case of convex lens, after refraction the rays are converging. Okay, like your concave mirror, after reflection the rays will converge. Okay, so both convex lens and concave mirror are converging in nature. Now we are going to see concave lens, how it behaves. Now you see the rays here. The rays, I am parallel to the principal axis. Let me take some rays which are parallel to the principal axis. You take the rays till the what is that? Middle of the lens, like that. Don't. Right. What happens? These are all rays. The light rays parallel to the principal axis. Okay, which after refraction by a concave lens, okay, will appear to diverge. From a point lying on the principal axis. Will appear to diverge from a point lying on the principal axis. Okay, and that point is called as the principal focus of the concave lens. Therefore, how to show that? The parallel rays. Now, okay, I have drawn. Okay, and after refraction, they appear to diverge from a point. Therefore, how to draw? See here, they will diverge. So, for that, first you fix the point. It will be easy for you to draw. That's why. Okay, otherwise, fix that point. Okay, here. Okay, one point. Therefore, after refraction, the rays, they appear to diverge from a point. Therefore, this is a point. From there, they appear to diverge. It goes like that. Okay, so like that here. It goes like that. Okay, therefore see, the rays are parallel. After that, what is it? It is diverging. It is not converging. It is going like that. It is diverging, right? Therefore, like that. Therefore, here also, you see, the rays, they, after refraction, they diverge. They appear to diverge from a point lying on the principal axis. With the scale, you have to draw. Okay. So, therefore, what is it? It is going and you extend in the opposite direction. That means it at one point, and that point is what is called the principal focus. That point is what is called the principal focus. See, actually, you have to draw like this, but it is because it may not, see, actually speaking, no, how to draw, see, this simple way I told you, this is okay, okay, this is your principal, and here is a ray. This ray, after that, what it will do? It will diverge. And when you are extending in the opposite direction, it meets at focus. Are you following? Like that, here the ray, it goes and it diverges. If you extend in the opposite direction, it meets here. Are you following? So, that is why it is simple. First you fix the focus, then it will be easy for you to draw. For drawing the what is a ray diagram? This is what is the ray diagram now. So it will be simpler. Before drawing itself, you fix F so that it will be easy for you to. Okay. So this is what is called the principal focus. Okay. Therefore, so listen. Therefore, what is principal focus of what? F is what is called the principal focus of a F is what is called the principal focus of concave lens. Correct? Concave lens. And here, what type of lens is this lens? It is a diverging, because the rays after refraction, it is diverging now. Therefore, it is a concave lens. Is a diverging lens. As your convex mirror is a diverging mirror. Okay, diverging. How to define principal focus of a convex mirror? The rays parallel to the principal axis after reflection by a convex mirror, okay, will appear to diverge from a point lying on the principal axis. Okay, and that point is called the principal focus of a convex mirror. Okay, therefore in both the case, what is that? The rays are diverging. Okay, here there after reflection the rays diverge. In the case of convex mirror, in the case of concave lens, after refraction the rays will diverge. That is why they are diverging in nature. That is, a convex mirror is a diverging mirror. Here concave lens is a diverging lens. Okay, right. But here one more very important thing is, see, I just want to tell you, there are, here this principal focus is fine, but actually for a lens, see, once again, for a lens, there are two foci. What do you mean by focus? Here is principal focus, na? But two sides are there, no? There are two surfaces, spherical surfaces here. That is, it is a transparent medium which is bounded by two spherical surfaces. Therefore, there are two principal foci. Foci means plural for focus. Okay. Therefore, if you want, see, I just want to draw convex first. Okay. The case of convex lens. Okay, here this is your principal focus. Okay, right? And there are, this is your O, that is optic center. Okay, and this side for one principal focus, and at the same distance here there will be one more principal focus. So how to differentiate? This is f1 and this is f2. For lenses there are, what is that, both the side, one end on one side, but is one each, okay, left side and right side, one principal focus, that is called as f1 and f2. Like that, the same thing here in the case of concave lens also. In the case of your concave lens, there are two principal focus, foci, okay. Therefore this is O, and if you want to draw, okay, usually, yeah, therefore here what is that, here is f1 and this side it is f2. There are two principal foci, okay, right. And another one here I just want to give you one. See, if the rays parallel, the parallel rays in the case of convex lens, the rays, parallel rays are coming means after reflection, after refraction, it passes through focus, correct? Parallel rays, after refraction, passes through focus. Like that, here in the case of concave lens, parallel rays, after refraction, it is after refraction, it appear to diverge from the focus. Appear to diverge from the focus. It passes through the focus, but it appear to diverge from the focus. Here it is f2, here it is f1. Are you following? See, this should be a straight line, ma. You see, very important here. See, once you are drawing, you use the scale. Okay, I tried my best to use the scale, but it takes lot of time. Okay, that is why I thought why to unnecessarily waste the time. Because it takes lot of time to orient the scale, that is why. Okay, so otherwise I would have used it. This is, yeah. Are you following? So this is, if the rays are parallel rays through convex lens, after refraction it passes through the focus. The parallel rays in the case of concave lens, after refraction, what it will appear to diverge from the focus. Okay, right. Next one, if the ray is passing, see, next one is very important. If the ray, whether it is a convex lens or concave lens, okay. So let me go for first. Okay, see, whether it is convex lens or concave lens, if you have one, see, for example, I have a convex lens. Say I just want to make the board colorful. Okay, that's why I'm using different but that should be contrast should also be maintained. I cannot use all the colors. Anyhow, see here. Okay, see, if the light is passing here, see, it is a focus, for example, f1. Okay, if the light passes through the focus, in the case of convex lens, the light passes through the focus, after refraction, then it will be parallel. After refraction, it will be parallel to the principal axis. Parallel means what is parallel to the principal axis. Are you following? See, very important. See here in the first case, in this case, the parallel rays after refraction passes through the focus. The next just ulta. What is that? If the incident ray passes through a focus, after refraction will be parallel to the principal axis. Okay.